Hi everybody. So in this video, we're going to look at calculating pressure as a measure of force divided by area. If you want to work along with me in this video, you can download a copy of a PDF from my website. I'll leave a link in the description below. So it's important to understand that pressure is a measure of any given force for one unit of area. And this will have units of force, which is in newtons, divided by the area, which is in centimeters squared. It could also be in newtons per meter squared, depending on the context of a question. So these are the units for pressure. Okay, so in example 1, we're asked to find the pressure exerted by a force of 900 newtons on an area of 60 centimeters squared. So if we write this as a ratio of force to area, we've got a force of the 900 newtons to an area of 60 centimeters squared. And the pressure will be the amount of force over 1 centimeter squared, so 1 unit of area. And then to go from 60 to 1, we just divide it by itself, so we divide this by 60. And the reason why it's force divided by area is because we divide for both sides by 60, and this keeps the ratio balanced. And when you divide 900 newtons by 60 centimeters squared, we get a pressure of 15 newtons per centimeter squared, okay? So this is our pressure here. For question 2, we're told that a block exerts a force of 10,000 newtons on the ground. The base of a block in contact with the ground is 4 by 2 meters. We've been asked to work out the pressure on the ground due to a block. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the worked solution. Okay, so welcome back if you had a go. So the first thing we need to work out is the area of the block which is in contact with the ground. And this is this rectangle. And we know it's 4 by 2. This will have an area of 8 meters squared. So now the pressure will be the force of 10,000 newtons divided by the area of 8 meters squared. When we work this out, we get a pressure of 1,250 newtons per meter squared. Okay? In our next set of questions, we're going to look at finding the force and the area when we're given pressure. So in example 3, we're told that a box exerts a force of 140 newtons on a table, and the pressure on the table is 35 newtons per meter squared. We've been asked to work out the area of a box that is in contact with a table. So do you want to try this question? You can pause the video, and when you come back, we'll go through the solution. Okay, so we've got a force of 140 newtons and a pressure of 35 newtons per meter squared. So we can substitute this into our equation. The pressure will equal the force, 140 newtons, divided by the area. So we need to make the area the subject of this equation. If we multiply both sides by the area, then these will cancel. So 35a will equal 140. We'll divide both sides by the 35. And this will give us an area of 4 meters squared. Okay? For question 4, a cylinder is placed upright on a table. The area of the base of the cylinder in contact with the table is 15 centimeters squared, and the pressure exerted by the cylinder on the table is 0.36 newtons per centimeter squared. We've been asked to calculate the force exerted by the cylinder on the table. So if you want to try this question yourself, you can pause the video and come back when you're ready. So we're given that the area is 50 centimeters squared, and that the pressure is 0.36 newtons per centimeter squared. So we'll substitute each of them into here. So the pressure will equal the force, which we're trying to find, divided by the area of 50 centimeters squared. We'll multiply both sides by the 50, and these will cancel. And 0.36 times 50 will give us 18 newtons for the force. Okay, so let's try some exam style questions. So now we're told that a box in the shape of a cuboid is placed on a horizontal floor. The box exerts a force of 180 newtons and a pressure of 187.5 newtons per meter squared. We've been asked to work out this value of x. So if you want to try this question, you can pause the video, and when you come back, we'll go through the solution. Okay, so welcome back. So the first thing we should do is to find the area that's in contact with the floor. This will be the area of this rectangle. So we'll just multiply the 1.2 by the x. And this will give us an area of 1.2x. And we know the pressure is 187.5. So we'll have 187.5 will equal the force of 180 newtons divided by the area of 1.2x. We'll move this over to the left-hand side, and then we can multiply out this bracket. So we get 225x will equal 180, and then we'll divide both sides by 225, so x will be 0.8 meters. Okay, let's try one final question. Okay, so finally, we're told that the diagram shows a solid cube on a flat surface, and the cube exerts a force of 56 newtons on the surface. The pressure on the surface due to the cube is 0.14 newtons per centimeter squared. We've been asked to work out the volume of the cube. So this is our final question. If you want to try this yourself, you can pause the video and then come back when you're ready. Okay, so again, we need to find the area of a cube that's in contact with the surface. And this will be a square of area a squared. We just multiply the length by the width. We know the pressure is 0.14 newtons per centimeter squared, and the force is 56 newtons. So 0.14 will equal 56 divided by our area for a squared. We'll multiply both sides by the a squared, and then divide both by the 0.14. We can work this out on our calculators, and we get a squared is equal to 400. So now we can work out the length of one side of our cube by taking the square root of both sides. So a will equal root of 400. This is 20. So now to find the volume, we'll find the area of this face, 20 by 20, which is 400. And then we'll multiply it by the height. So the volume will be the area of the base multiplied by the height. And this will give us 8,000 centimeters cubed. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link in the description below.